Today I am going to simulate the full wave rectifier without filter. First, let us build the circuit. We need to place the required components. Go to Place, Component, Power Sources, or you can go for Signal Voltage Source, so which gives a peak value of the AC voltage. So if you go to this Power Sources and AC Power, it will generate the RMS value. So here Vrms equals to Vm by root 2. So we can select either one of these two types of AC power sources. So I am going to select the peak voltage, that is signal voltage source. Here go to AC voltage, which will generate some AC voltage with the peak value. Next, go to power sources. Here ground. Place the ground. Next, we need a transformer. Go to basic. Here we have a transformer, TS transformer tap. We are using center tap transformer. Select this center tap transformer. Click OK, and then place this transformer. Next, we require diodes and resistors. Here in this basic itself, we can select the resistor. I am selecting 100 ohms resistor. Next, go to diodes. I am going to select 1N4007 GP. And same diode I am going to select. Next, select indicator. Here we require ammeter for measuring DC current. We placed all the required components. Then we need to rotate the center tap transformer. Just click on right click and then flip horizontal. So it will rotate horizontally. Then this resistor, right click 90 degrees clockwise, rotate this transformer resistor. We can make the connections now. Now, in order to measure the AC and DC voltages, we require a multimeter. We can use two multimeters simultaneously, one for measuring the AC and another for measuring the DC value. Then in order to view the waveforms, we can use the oscilloscope for viewing the input and output waveforms. So the channel A is connected to the input waveform. Then channel B is connected to the output. We are using two multimeters, one for AC and another for DC. Now set this multimeter one for measuring DC voltage. Here we are selecting a voltmeter, and this straight line indicates the DC value. And similarly the multimeter 2, which we set for AC voltage. This is AC voltage. Next we will set the input to 230 volts. Here we can set the transformer turns ratio according to our requirement. Here I am going to use 12 volts peak AC voltage. So in order to have 12 volts, we need to use the transformer turns ratio as 12 by 230 volts, which is 0.05217. That is 12 by 230 volts. So if we give 12 volts peak here at the input itself, we can directly give the turns ratio as 1. So we can set this turns ratio based upon our requirement. And then we will start the simulation now. So here we can observe the waveforms in the oscilloscope. So here, as we can stop the simulation also now. As we have given 12 volts input, we can set this channel A for 10 volts, and similarly the channel B is also for 10 volts for 1 millisecond. And then if you change this Y position for channel B, this is channel B is the output. So like this, the waveform, the output waveform is rectified. This is your input AC signal, and this is your rectified output or pulsating DC. So in order to view the voltage, you can use this traces also. The peak value is around 12 volts. Here we can view the voltage also, 11.997 volts. That is approximately 12 volts here. And similarly, we can view this rectified output also. This half of the frequency is the same here, half cycle, and here also rectified one. This is your output waveform. And next here we have this DC value, and this is AC value. Now we can close this waveform, and we will have these values for measuring the ripple factor. So we set this load resistance RL as 100 ohms. So for 100 ohms, the DC current is 69 milliamperes, and here the units is amperes. This is a 0.069, that is 69 milliamperes, and VAC is 3.624, and then DC is 6.939. So similarly, we will repeat this simulation for different load resistance values. We will increase this load resistance in steps of 100 ohms. Till 1 kilo ohm. Now the DC current is 35, and this is a 6.983, 3.627, next for 300. Then the simulation. Stop. Note down the value here, 23 milliamperes and 7. 3.63 and 7.007. This is the DC value. And similarly, if you repeat this for 400, then the simulation. For 400 load resistance is 18. AC is 3.632 and DC is 7.024. Next, if you run for 500, $14, 3.632, 7.038. Next, for 600, $12, 3.633, 7.049. And similarly for 700, is 10, 3.634, 7.058. And similarly for 800, $8.832, 3.634, 7.066. And similarly for 900, so as the load resistance increases, the current decreases and the DC voltage increases. Now for 900, 7.861 and here 3.632, here 7.074. And if you observe for 1 kilo ohm, for 1 kilo ohm it is 7.080, this is 3.635 and 7.08. So like this we got the values, AC and DC values. So now we are going to find out the ripple factor. The formula for finding the ripple factor is VAC by VDC. So now just click on this cell and just put equal sign, then select VAC, then type divide by symbol and then VDC value and just tick. Now we got this ripple factor value as 0.52. And similarly select this cursor and drag. Now we have obtained the ripple factor around 0.51 average value. Ideally we need to get 0.48.